Welcome. Today we're going to graph our quadratic function and we're going to find its roots. So here's my function. F of x equals x squared plus 6x plus 8. Now notice that I have addition for both of these terms. I don't have any subtraction, so I don't have to do CSA. But if I did have subtraction, that would be the first thing that I do. Now it's a function, so I could graph this just by creating a table like this, x and f of x, and putting values of x into this function and getting a value of f of x, which would be my y on my graph. I could plot those points and then see what this graph looks like. Now I could do that, but it'd be a little slower, and so I'm going to use my knowledge of this function, this type of function, in order to do it a little better. So it's in the form of ax squared plus bx plus c, which I know is going to give me a parabola. Now a parabola, if you remember, is going to be that U-shaped or V-ish U-shaped object. It's going to look like this, or it could be upside down, it's going to look like this. Okay, so here's what we know. We know A, B, and C. A is 1. It's hidden here, but it's there, right? B is 6, and C is 8. Okay, so what do we know about these A, B, and C's? We know that 8, in this case C, is our y-intercept. So right off the bat, we know 1 point on our graph. So I'm going to go ahead and put that in our table. Okay, the y-intercept is 0, 8. Okay. The y-intercept always has a value of x. The x value of the y-intercept is always 0 because it's always on this axis. Okay. So we have 1 point. The y-intercept is not the most important point on a parabola, but it's a quick and easy point we can get to get us started. All right. So what else do we know? We can find the axis of symmetry because we know that all parabolas are symmetrical. There's always a line that cuts them in half, and they're the same on each side of the line. If you folded at that line, you would find that the parabola is the same on both sides. All right, so here's my formula for finding the axis of symmetry. I can go ahead and plug my b and my a into that. Okay, so it'd be x equals, I know that b is 6, so it'd be negative 6 over 2 times a is 1, 2 times 1, and we'd have negative 6 over 2, which is negative 3. So x equals negative 3 is my axis of symmetry. Okay? Now remember, x equals negative 3 is a line. It's a vertical line that's saying no matter what the value of y is, x is always negative 3. So whether x is 0, whether y is 0, y is 10, or y is 1,000,000, x is always negative 3. So I'm always going to get a vertical line. So I'm going to go ahead and plot that line. I'm going to use the computer to cheat to give me a nice pretty dashed line. And there it is, x equals negative 3. That's my axis of symmetry. Okay, so far we have 1 point, which I'll put on the graph, 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. There it is. And I have my axis of symmetry. Okay, I can use my axis of symmetry to find my vertex. Okay, the vertex is a really, really important point on this graph. Okay, so let's go ahead and find that. So how do I do that? I plug in my x value of my axis of symmetry into my function. So I'm going to find f of negative 3, right? Because this negative 3, I can plug right in here. It's got to be on this line. The x value has to be negative 3. So I'm going to go ahead and plug that in. So I have negative 3 squared plus 6 times negative 3 plus 8. Negative 3 squared is 9 plus negative 18 plus 8 equals negative 1. All right, so my y value of my vertex is negative 1. So I can write down here, I'll write it as an ordered pair, negative 3 comma negative 1 is my vertex. All right, that's really useful. So I'm going to put that in my graph. Gives me another very important point. All right, so negative 3, negative 1, which is right here. Okay, so we know that our vertex is here, and we know that it's either the maximum or the minimum value of our parabola. In this case, we can tell that it's a minimum value because my a, which is 1, my a right here is a 1. That means that it's positive, which means that this parabola faces up. The open end of the parabola is going to be facing up. Okay, so we know it's going to look something like this. It's going to be U-shaped. All right, so now we just need to flesh this out a little bit. So let's go ahead and create a little space to work in. All right, let me get rid of some of this stuff. All right, So let's find a few more points. I'm going to put one in between these two on this side of the axis of symmetry. So I'm going to pick this one here at x equals -2. I'm going to find f of -2. So I can see what's happening. So I have -2 squared plus 6 times -2 plus 8. -2 squared is 4. 6 times -2 is -12 plus 8. 4 plus -12 plus 8 equals 0. All right. So when x is -2, f of -2 is 0. All right. I'm going to go ahead and plot that. All right. Now because we know that our parabola is symmetrical, I can guess that there's going to be a point right on the other side of that axis of symmetry at the same spot. So here, this point right here, 0, 8, is 1, 2, 3 away. Right? It's 3 away from my axis of symmetry. So if I count 3 in the other direction, 1, 2, 3, I should have a point right here. Right? And this would be -6, 8. I'm going to write that in my table. I'm going to be bold and write that in. And I'm going to go ahead and confirm that that point exists on my parabola. Okay? I'm going to find f of -6. All right? So that should equal -6 squared plus 6 times -6 plus 8. All right, -6 squared is 36 plus 6 times -6 is -36 plus 8. So these two are going to cancel, and I'm left with 8. F of -6 equals 8, just as I figured. Let's go down and find this point here. This one right here, this is -2, 0. This is exactly 1 away from my axis of symmetry. So 1 on the other side of that, there should be another point. Now that is -4, 0. I'm going to go ahead and write that in, and then I'll confirm. I'll confirm once I do a little erasing here. All right. All right, let's find f of -4. If it'll let me. There we go. F of -4 equals -4 squared plus 6 times -4 plus 8. -4 squared is 16. 6 times -4 is -24 plus 8. 16 plus -4, -24 is -8 plus 8 is 0. So I was right. So f of -4 is also 0. So now I have 5 points on my graph. And I can plot my parabola. My parabola is going to go right over these. Instead of drawing them freehand, I'm going to, once again, have my computer draw it for you, just to make it pretty. And there we go. There's my nice-looking parabola. Okay? So, last thing I want to do is find my roots. Now, my roots are my x-intercepts. So I just look and see where this graph crosses the x-axis, right? The y value is going to be 0. And I've actually got a couple of them in my table. Right? Y is 0, f of x or y is 0. So that's a root. And that's a root. Right? And we can see them right here. Now remember, on a parabola, it can either have 2 roots, like this one. It could have 1 if the vertex was on the x-axis. Or it could have none. Like if I move this whole parabola up higher, I push this whole thing up so that it doesn't cross the x-axis at all, then it would have no roots. So that's it. That's the whole thing. So I hope this was helpful to you, and I'll see you in class.